Chapter 4, Section 12, Missing Data Imputation, Part 6, Multiple Imputation by Python. Let's implement multiple imputation by Python. First, import the necessary libraries. First, import NumPy for numerical calculations and Pandas for data manipulation and analysis. Then, import KNN imputer to use for initial imputation. Then, import linear regression to use as the prediction model. Then, import MAE and MSE to evaluate the model's prediction performance. MAE calculates the average of the absolute values of the differences between the predicted value and actual value. MSE calculates the average of the squared errors. The larger the error, the larger MAE and MSE will be, indicating the low prediction performance. Next, create a dataset and convert it to a data frame. Next, we will perform initial imputation using KNN imputation. We can do it in the same way as normal KNN imputation. First, create an instance of KNN imputer. Set k to 2. In the next part, apply KNN imputation using fit_transform and convert the results to a data frame. Fit_transform learns the features of the data using fit and then impute the missing values based on the learned features using transform. In this part, we create multiple imputed datasets by adding random variation to the data after initial imputation. Below, I will explain the code line by line. First, use NumPy random seed 0 to ensure the reproducibility of the random numbers. The same random numbers will be generated each time. We can obtain the same results each time we run the program. This ensures the consistency of the experimental results. Next, create an empty list named imputed_datasets to store the multiple imputed datasets. We will add each imputed dataset to this list one by one. Then, using a for loop, we create 3 imputed datasets by a 3-loop process. Inside the for loop, we create a copy of the initial imputed dataset named df_imputed. By using a copy, we will avoid overwriting the original data. In the next line, NumPy random normal 0, 0.2 generates random numbers that follow a normal distribution with a mean of 0 and a standard deviation of 0.2. We add these random numbers to the satisfaction values in S8. By doing so, slightly different imputed values are set for the missing satisfaction values in each dataset. Finally, using append method, we can add the imputed dataset created in the for loop to the list named imputed_datasets. Now, let's display the 3 datasets we created. By combining the for loop and enumerate, we can display the datasets with their index numbers. Right after for, there are 2 variables, idx and dataset. The first, idx, is the index of the dataset, and the second, dataset, refers to the dataset itself. Here, we use enumerate, and the first argument is the list imputed datasets. This will iterate through the list imputed datasets, taking the index of the dataset and the dataset itself one by one. The second argument of enumerate is 1. This means that the first number of the index is 1. In Python, the default first index number is 0, so we set it to 1 here. The next two lines print the index first, and then the datasets. When we run this code, 3 datasets are displayed in this way. You can see that each dataset is displayed with its index number. You can also see that the missing values for satisfaction in S8 have been imputed with slightly different values. In this part of the code, we perform a linear regression analysis individually for multiple imputed datasets, and the results are saved and displayed. Results is an empty list used to save the results of the regression analysis, such as intercepts and the regression coefficients obtained from each dataset. Using a for loop, we perform regression analysis on each of the multiple imputed datasets one by one. Here, we use enumerate to give each dataset an index number. By giving each dataset an index number, we clarify which dataset the results were obtained from. We include the independent variables, motivation, and stress in X. Independent variables are factors that affect dependent variables. Set the dependent variable satisfaction to Y. Dependent variables are variables explained by explanatory variable, and in this case, we will use regression analysis to predict satisfaction. Use a linear regression to create a linear regression model. The fit method trains the model using the independent variable x and the dependent variable y in the imputed dataset. The model learns how motivation and stress affect satisfaction and calculates the optimal regression coefficients and intercept. Model intercept gets the intercept of the regression equation. This is the predicted value of satisfaction when motivation and stress are 0. Model coef gets the regression coefficients corresponding to each independent variable. Model coef 0 shows the regression coefficient for motivation and shows the effect of motivation on satisfaction. Model coef 1 shows the regression coefficient for stress and shows the effect that stress has on satisfaction. These results are converted to a dictionary format and added to the results list. The results of the regression analysis obtained from each dataset are displayed. The intercept and regression coefficient are displayed, and we can check the effect of the independent variable on the dependent variable. In this part, we summarize the results of the regression analysis obtained from multiple supplementary datasets. Besides, we calculate the average values of each regression coefficient and intercept. This is an important step for integrating the variability in the results from each dataset and obtaining a highly reliable final estimate. In the previous slide, we stored the results of the regression analysis for each imputed dataset in the list named results. Here, using Pandas data frame, we convert the list-style regression results into data frame. This enables us to manage the result of multiple datasets together and easily calculate the mean for each column. Then, we use the mean function to calculate the mean value for each column. By doing so, we can obtain the average values of intercept, motivation regression coefficient, and the stresses regression coefficient. These averages represent the final estimated values that integrate the results of the analysis of the 3 supplementary datasets. In this part of the code, we use Rubin's rules to calculate the standard error, considering the variance in the results obtained from multiple imputation datasets. This enables us to obtain results that appropriately reflect the uncertainty caused by missing data imputation. The var function is used to calculate the variance between the imputed datasets. In Rubin's rule, the variance between the datasets is divided by the number of imputed datasets used. Here, we use 3 datasets, so we divide it by 3. By doing so, we can integrate the results from the 3 datasets and calculate a variance that reflects the overall variance. Next, we use NumPy score to calculate the square root of the variance, that is, standard error. Then, we display the standard error calculated in the final step. The standard error reflects the uncertainty of the missing data. Finally, print the pooled regression equation. In multiple imputation, multiple imputed datasets are created, and the results are integrated by analyzing each dataset. This enables us to obtain highly reliable estimates that consider uncertainty. If you want to use the imputed data for other analysis, the correct way to use multiple imputation is to use the 3 imputed datasets as they are, analyze each dataset, and then integrate the results. If we want to use only a single imputed dataset for another analysis, we can average the 3 imputation results and integrate them into a single dataset. However, we should be aware that this method does not match the purpose of multiple imputation. The purpose of multiple imputation is to reflect uncertainty using multiple candidates and to perform a more robust analysis than when using only one imputed value. Thank you for watching. Please thumbs up and subscribe to my channel.